Ya, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazmi bin Anuar and my metric number is DE100140. So for today's video, me and my friend will elaborate about the activity number 3, which is the open loop and closed loop position control. I will be explaining about the activity 3.3.1, which is the open loop position control. So for the first question, which is it asks to construct the plot diagram based on the figure 3.4 using MATLAB Simulink. Here is the plot diagram that I construct, and then the second question asks to key in all the parameter value into the Simulink block, which is from table 3.1. I have substituted the value of the parameter given. And then the next question, which is the number 3. For the next question, which is the number 3, which is question asked to check the block Simulink by keying the input angle value is 1, and the attenuator gain is the value is 1 also, and if the input voltage and shaft motor position display show the values, it means the block is function. Going to change the value into 1 and 1, and then we run. So as you can see here, you can see the output at the input voltage, which is 0.6111, and then at the shaft power position, which is 11.73. Next, we are going to proceed with question number 4, which is to increase step by step the value of the input angle, which is here in the input angle from 0 until 10, and then the attenuator gain is 1, and we have to observe the shaft motor position display and what happened to the system. So the step by step, which is the angle, we have to set from 0, and then the attenuator gain 0 also. So when I run, you can observe the circuit did a function because the shaft motor position value is 0, same goes to the input voltage, it also 0. Then change the value of the, and we get the value of input voltage, which is 0.611, but the shaft motor position remains 0. Then we change to 2, and the input voltage is increasing 1.222, and the shaft motor position remains 0. Then let's say if I put it 10 here, so the value is increasing to, the value of the input voltage is increasing to 6.111, while the shaft motor position is still remains 0. So what I can conclude for the system is when the input angle is increasing, the value of the input voltage which will increase, but the shaft motor position didn't appear any value, which is the circuit here did not function. Next is I'm going to explain for the question number 5, which is to increase the step-by-step value of the attenuator gain from 0 until 10 and set the input angle 0. So input angle we have to put 0 and step 0. So when we run it, the value of the shaft motor position is 0. Change the value of the attenuator gain to 1. Still didn't change. 2. Still didn't get any value. And lastly, okay, put the value here. Still doesn't have any value. So what I can conclude here is the system didn't work, which is there is no input angle, so the system will not be able to operate as usual. So I think that's all the explanation from me. So I will pass to my friends to elaborate for the activity 3.3.2, which is the closed loop position control. So thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. First of all, my name is Muhammad Hazmi bin HALIM, and my metric number is DE205. Okay, for this lab, me and my friend, which is Muhammad Nizam, will do this activity 3.3.2, which is the closed loop position control. Okay, for not delay any time, let's go to the video explanation. Okay, for the first step, we need to construct the block diagram, which is stated in the figure 3.5 using the MATLAB symbolic, which is we have done construct the circuit, the block diagram as shown in the lab sheet like this. This is okay. Okay, we have done complete the construction of the block diagram. Okay, for the step number two, we need to in all parameters values into the assembly block, which is the all the parameter is from here. All the related parameter we need to key in this block diagram, which is LA, RA, JM, BN, DP, PP, and so on. Okay, so we have done complete key in all the parameter like this. We have done change the denominator and so on. Okay, that's for the step number two. Okay, for the step number three, we need to check block symbolic by key in input angle value is 1 and the emitter gain value is 1. And if the value of the input voltage and shunt motor position is displayed, it means the block diagram is this block diagram is function. So I change to 1 for the input voltage, input angle, and emitter gain I change to 1. So 1, okay, I run. Okay, so the shunt motor position and the input voltage display the value. So it means this block diagram is functionable. So that's for the step number 3.
Assalamualaikum. My name is Muhammad ZAHARI. My matrix number is CE 210005. Today I want to present about the activity 2 and I do the step 4. We need to increase step by step value of input angle from 0 till the 10 and set the attenuator gain is 0. The attenuator gain is 0 and I set the input angle 5 and get the result. The shaft motor position is 0. Then I switch the 0 until 10 and I go to 8 and get the shaft motor is 0. And then I go to activity 2 for the question 5. The increase step by step value of attenuator gain from 0 till 10 and set input angle 0 and observe the shaft motor position. Okay, and attenuator gain is 0 and input angle I go switch to 4. Okay, and go to run and get the shaft motor position is 0 and I switch the value angle and go to 7, apply and OK and get the result. The shaft motor position is 0.
For the step number 6, we need to set input angle 550 to 160, positive for potentiometer clockwise and negative for anti-clockwise and completely stable. Okay, for this step, we need to follow the rules, which is if clockwise, we need to for the input angle position, we need to put positive 5 in this input angle, positive 5, enter. The editor again is 1 and then we run. Okay, the dah fire. Bye. Don't forget to don't forget to put sign positive. Okay, the value of the motor position is 3.927. The input voltage is 3.056 and the output voltage is 2.4. That's for the input angle positive 5. And then we change to negative 5. And then we run. We got the same value but in the negative way. Okay, then we change the input angle to positive 150 and the electric is 5. And we run. We got Shah motor position 138.5. The input voltage is 91.67 and the output voltage is 84.61.
And then for 150 for anti-clockwise, I take the negative, this input angle, the negative 150, and the attenuator gain is 5. The gain is 5, and get the input voltage, output voltage, and shaft motor position. And then I get the input voltage, shaft motor position, and output voltage. Then I switch to 316 for the positive. Okay, right, and the attenuator again 8, apply, and okay, then run and get the all input voltage, shaft motor position, and output voltage for the clockwise. And for the anti-clockwise, I just twist it here, negative, and apply, and okay, and go to run and get the input voltage, shaft motor position, and output voltage all negative. Okay, that's all from me. Thank you.